All right, MS-DOSX, let's get started for today. Today we are going to start actually writing apps and teaching you guys how to play with Interface Builder, which is the graphical editor for designing user interfaces. So today is going to be Mac heavy, and then Thursday we'll be covering kind of the differences for iOS. You're going to see it's pretty much the same. There's just a few. iOS is just a bit more limited, but Mac is where it started, so that's where we're going to start today about making interfaces for Mac. And before we get into the details of actually making interfaces, there's a paradigm that Apple strongly recommends that all apps adhere to, and that's a paradigm called the Model View Controller paradigm. And it's a really handy design paradigm when you're designing an application to make your code really reusable and portable, and really makes it easy to make apps and keep them not super messy in terms of the code. So there are, obviously, as you might guess, there are three parts to the Model View Controller paradigm. There's the model, there's the view, and the controller. The model is pretty straightforward. It's sort of your data model. It's going to keep track of the state of your application. The important thing is that the model is not at all connected to the UI. It doesn't know what it means to present data to the user. It just has a way of storing data. So in the case of a fraction calculator, a fraction class that just keeps track of a single fraction instance, that might be an example of a model. But the idea is that a model is just data, and that's it. Nothing else. No interface, just data that your app can use to play with and present on the screen in some useful way. On the other side, we have the view, and this is the part the user sees. This is the user interface. The point of the view is that it displays in some way to the user the contents of your model. And the important thing is that the view doesn't generally store state. In particular, it may store a little bit of state to kind of keep, just for efficiency reasons, to kind of cache the interface. But generally speaking, the view doesn't store any state. If your application needs to store state, it belongs in the model. And we'll see in a second why it's useful to separate these two. And then kind of mediating between the view and the model is that either a single controller object or a collection of controller objects that kind of anytime the content of the model changes, it tells the view, hey, the view needs to be updated because the model's been changed. Or anytime the user interacts with the view, they press a button that causes something to happen in the model. The controller receives that input from the view and then tells the model to change. So the idea is that the view and the model aren't really supposed to communicate directly. So if we imagine we have three parts of our application, the model, view, and the controller, you really should imagine there being a brick wall between the view and the model. They really shouldn't communicate directly, but they can communicate by communicating through the controller in the middle. Anybody have a guess why this is what makes this useful? Yeah. Yeah, one useful thing is, suppose I want to write an app that works on Mac and on iOS. It'd be stupid to have to write my model logic twice. So why don't I just make a single model that's kind of totally no UI whatsoever. It just kind of keeps track of the state that my application needs. And then I can write a custom view for each one, and then I just have to tweak the controller a little bit for each platform. The other really huge benefit is if you want to change the underlying representation of your model, if you do it with Model View Controller, you don't actually need to change your view code. Doesn't need to change at all, because you just have to maybe change the controller logic a little bit, so that way it communicates with the new model. And similarly, if you want to totally revamp your UI, you don't have to also change your model code. So it nicely separates the front end of your application and the back end. Okay, so I think the best way to show you how to make a UI in Interface Builder is just to do it. So let's make a really simple user interface using Interface Builder. So if you're using Xcode 3, Interface Builder is actually a separate application. In Xcode 4, it's been integrated. So ask us if you're not sure where it is in Xcode 3. Everything is going to be using Xcode 4. So I'm just going to make a simple, just a view-based application. I'm going to call it slider. We'll see why. Oh, did I make an iOS app? That's not what I wanted. You'll see on Thursday that it actually doesn't really matter. They're basically the same, but I'm just going to make a Mac app real fast. So small. Okay, so a skeleton Mac app project doesn't give you a lot. It gives you really sort of a main.m, which is where your application gets launched, and then this funny app delegate class, which we'll talk about a little bit later, but it's kind of the launching point of your application. And then it also gives you this main menu.xib file, which historically these were called nibs, because it used to be .nib was the extension, but it's a graphical version of your user interface. Golly, that's small. Okay, so here is the window that's going to get displayed on screen when we launch the application. So if we just run it as is, you'll see that we're just going to get this window with not really a lot going on in it. Yay, there's our application. Super interesting. But one of the really cool things about Interface Builder is that the way you put elements in the interface, man, this is small, is you just drag them in. If you want a button, you drag in a button. If you want a text field, you just drag in a text field. And you can position these anywhere you want. And you'll notice that that Interface Builder is giving me these blue guidelines. These are the guidelines that the Human Interface Guideline recommends for how far apart the different elements need to be. So it knows the rules that a button should be that far from a text field, and all those other rules to kind of to get line up baselines and all those good things. So those are really useful in helping position your elements, so that way it makes sure that they actually look decent. So for this application, what I'm going to grab, you can see for Mac, there's a huge variety of objects that you can put into your interface. What I want is I just want a horizontal slider, and I can resize it here. I can never get over how small this is. Okay, I'm going to put a slider, and then I'm going to put a label. And so the idea of this application, it's really simple. I'm just going to have this slider, which is going to have some value between 0 and 100, and the label will just update to show what the value in the slider is. So there is a panel over here on the right. Again, in Xcode 3, this is a separate window. It's called the inspector window, but there's multiple tabs to this window, this inspector, to allow you to kind of customize different elements of this widget. This one here is useful because this allows you to control basically all the properties of it. So you can change the text color, you can change the text alignment, you can change the font, all these kinds of things here. So the best way to kind of get used to this is just sort of playing with them and just dragging elements in and seeing what you can manipulate. For the slider, I'm going to have it go from 0 to 100 and starts at 50. Okay, that's good. Okay, so we can save that. Now if we run this, we'll get that same window with those elements in it, but again, not really much else. Okay, so now we have a slider that we can slide back and forth, which is great, but we don't really know yet how to make anything happen when the slider slides, so let's learn how to do that. Okay, well, we'll get to that in a second. But before, one thing that's really useful about Interface Builder and I guess Mac and iOS apps in general is that views and all those different controls can have various auto resizing properties set on them, so that if the window resizes, all the controls will automatically shift around and resize according to the new window size. So you don't actually have to write logic for that. For every time the window changes, you have to reposition all of your elements. There's actually automatic tools for that. And so you just basically set some properties about when there's resizes, what you want to have happen, and then Cocoa takes over and actually does all the logic for that. And it uses what they call the struts and springs model. There are 4 struts around the side, and then there are 2 springs, one vertical, one horizontal. So, for example, the strut on the top says anchor to the top, which basically means that whatever spacing, and I should note here that the white square is the parent view, and then the turquoise view is the view that is the view we're talking about. We're setting the auto size properties on this turquoise view relative to the view that it's contained in. Does that make sense? So views can be set up in this hierarchy of views within views within views within views, and all this auto resizing is always done relative to however your parent does it. So anchor to the top means maintain the distance between my sort of top edge and my parent's top edge. Anchor to the bottom means maintain the distance between my bottom edge and my parent's bottom edge. Similar for left and right. And then the springs across the middle means that the width it can stretch left to right, and then vertical means it can stretch up and down. Those more or less make sense. And then you can just set these properties in Interface Builder. You can actually just physically click a little window where you just turn them on or off, and then as you resize the window, the controls will stretch or shrink as you resize the window. As of Lion, there's a really cool system called Auto Layout that's very, very complicated, and I'm not going to talk about it because it's very, very complicated. It's really very cool though, and it allows you. So like I mentioned, when you're playing with Interface Builder, you saw all those blue guidelines that Interface Builder recommends for what adheres to the human interface guidelines. Auto Layout basically codifies all of those guidelines, those blue constraints, and then just basically defines constraints between your different controls. So there's a constraint that these two controls must be 20 pixels apart, or there's a constraint that these two controls must be side by side, or these two controls must be vertically aligned, or something like that. And then so it's a much more general system than struts and springs, and so there's a lot of benefits you can get from it. I'm not going to go over these, but it's a pretty cool system if you've ever played with it. But like I said, it's complicated, and I'm not going to go over it now. Okay, so getting back to sort of motivating this UI that we're designing. So we have this UI, we have this slider in it, we have this label in it, but we don't know how to know when the slider changes, or when the slider changes, how to change what's in the label. That's what we want to do, right? We want to be able to, every time the slider changes, to change the contents of the label. And more generally, what we want to be able to do is we want to be able to link this graphical user interface that we've designed in Interface Builder to actual code in a class somewhere that we've defined in Xcode. And there's two parts to this. There's what are called outlets and what are called actions. An outlet is just a reference in code to an element in your user interface. Does that make sense? It's just a reference from your code to an object in your actual interface, actually in your nib file. And then an action is a way for you to specify when something happens to a control, what to do. Basically, it's like what object do you want to send a message to, and what message do you want to send when something happens to that control. And Xcode and Interface Builder have a really neat control drag interface to attach these, and I'll show you those in a second. So an outlet is really simple. You just declare usually an instance variable or a property. You just add the IBOutlet keyword in front of it. It's actually not defined to be anything by the compiler. It just gets defined away. But it's a flag that Interface Builder checks for to see if there are any user interface elements that can be linked to from the Interface Builder document. One thing to watch out for: there's a method awake from nib that gets called on every object after the nib has been loaded, and outlets aren't guaranteed to be linked until after that method has been called. So if you try to, for example, if you try to access one of your outlets in say your initializer, it's not guaranteed to be connected yet. You have to wait until after awake from nib has been called. I think you'll see that in the lab today. I can't remember. Okay. And then on the other end, you have actions, and actions are pretty simple. It's just a method that returns nothing. Again, we have a special keyword IBAction, which is just again a flag for Interface Builder to see, okay, this is a method that I can call from my user interface. But again, it's actually just defined to be void. You have some method with a name, and then it takes in as parameter the object that sent the message. And that's really useful so that you can know if you have a bunch of buttons that all basically do the same thing. It would be silly to have to write a receiver method for every single button. You can actually just send all of those to the same receiver method, and then just key off of the title of the button or the tag number of the button, so that way you can know which button sent the message. And on Mac, the sender argument is required. On iOS, it's not. You can have a no parameter action. So, like I said, you can manually set actions on the controls. Again, using Interface Builder, and you'll see how to do this. You just use Control Drag to attach them. There are also methods on all these controls: set target and set action. And basically, what this means is the target is when something happens to this control, who do I send a message to? And then the action is when I want to send a message, what message do I send? Does that make sense? I know this is kind of fast and vague. Any questions so far? Okay, so one thing you might be thinking is that that a nib is actually just generated code that generates the same UI. It's worth noting that everything you do in Interface Builder you can also do in code. I very rarely use Interface Builder anymore, at least for iOS, because there's not a lot you can, like, iOS is so simple that almost everything can be done equally efficiently in code and much more custom. A lot of the stock iOS interface elements don't look very good, I think. Like the stock button doesn't look very good. But when you're starting out, it's really useful to be able to just drag things into your window and then have an interface. But it's worth noting that nibs are not code. They're actually just a serialized set of objects, which just means a bunch of objects written out to file in some canonical format, and then those get read back in and then created on the fly as the program gets launched. And then the nib loads up. It connects all the outlets and all the actions on everything in the nib, and then it calls awake from nib on every object in the nib, saying, "Okay, the nib has woken up. You're ready to go now." Okay, so now tying this back to Model View Controller, suppose we're making an address book application. Our model is probably a bunch of address cards, so they have a photo for the person, they have a name and, say, an email. And then our view might look like something like this, where we have their picture and their name and their email in this nice little window. And so we might be tempted just to say, okay, view, just get all that data directly from the model. But we don't really want to do this, right? The view should never get its data directly from the model. It instead should mediate through a controller object. It will ask the controller for the state, and then it will use that to update the UI. And then we can also, anytime the model changes, we can report to the UI that it needs to be updated. And then now, if for example you click on the email address, we'll call a method on the controller, which will then request the email from the model, and then you can send an email to that address. Does that make sense? Okay, so now let's actually set up outlets and actions for sliders, so that way we can get that slider to talk to our code. Okay, so one thing to note is in this nib, we have, what do we have? Where's the app element? So there's what's called a proxy object here in this nib. It's a proxy object because it's not actually in the nib. It's just gonna when it launches, it's gonna create a reference to it. But basically in this nib, we have a reference to this app delegate object. The idea of the app delegate is that it's kind of the object that's responsible for getting your application up and running, and anytime you quit, it lets you know that you're about to quit, and that's kind of where all that stuff happens. So we can, since I don't want to waste time making an extra class, we can just, if we want the slider to do something, we can just send a message to our app delegate saying, "Hey, something happened. You need to make a change." So in some sense, our app delegate is going to act as our controller object. There's not really going to be a model because it's kind of just really simple. It's just a number, so there's not really a need for a model in this case. But if you have some more sophisticated application, then you should have a separate model class to keep track of the state of your application. So let's first, what should we do first? Let us, okay. Let's have this slider, every time it changes, call a method on our app delegate. So what we're going to do is we're going to go into our app delegates header. We're going to declare an action method. So what's the return type of an action method? IB action. And you can notice that Xcode is actually smart and knows that I'm declaring an action, so it will give me some skeleton name for it. So we'll call this slider changed. And since we know this is going to be UI slider or an NS slider, we can say that that's a slider. Okay, and so now let's provide a body for this in the implementation of this class. And for now, let's just ask the slider for its current value and log it out to the console so that we can see what the slider's current value is. And so we'll take a string. I think it comes out as a float. So we can say sender float value. Okay, so now in order to make sure that that slider, every time it changes, calls that method, we go into our nib. We're going to select the slider, and there's actually about 5 ways to do this, which is kind of useful if you forget one. One easy way is to control drag from the control to the object you want to send the message to. So in this case, we want to send it to the app delegate, and then you just let go, and it gives you a pop-up of all of the actions that it detects from the header file, and it sees that slider change is there and is marked as an action. So I can say, okay, I want you to call that method when the slider gets changed. And on Mac, every control has a single event that causes an action to be called. On iOS, you can actually send a lot of different actions. We'll talk about that on Thursday. But for example, a slider is set up so that every time its value changes, it fires its selector, whatever it happens to be. In the case of a button, when the button gets clicked, then it will fire the method, and that sort of thing. Another way to set up this connection is if you go back to the inspector, there's this connections panel, and you can also see there's this sent actions, which is the selector that it sends when this control's action happens. So in the case of a slider, again, it's when it gets slid. So again, we can just regular drag from here to the app delegate and click on and say slider changed. And so now if we run that with this really tiny window, if the demo gods are willing. Okay, so now if I did this right, when we drag the slider, okay, I didn't do it right. What did I miss? Oh, there it goes. Okay, so that's actually, so every time we let go of the slider, it fires an event saying that the value of the slider has been changed, and here's the new value of it. Yes. So as Daniel pointed out, there's an additional property we can set on the slider. That's there's this checkbox continuous, which will every time this will fire a method every single time it changes, even if the cursor is still pressed, even if the mouse is still pressed down. So we're going to get a lot of events, as you'll see. And so you can turn that on or off depending on what you need. So now you can see every time it changes, we get the new value. Yeah.
When you control drag it, is code generated or is it just saved? How does that work?
It's basically magic. It kind of is. It's still mysterious to me a little bit. It's not really code that it generates. It just Again, since method dispatch in Objective-C is so dynamic, the control just kind of stores all it stores is it stores that selector. It just stores that selector, and it stores the sender object, or sorry, the target, and then it just knows to call that selector on that object every time an event happens to it. And so that logic is already just inherent to the implementation of a slider, for example. And so you're just basically specifying when an event happens, which object to message and which message to send. Does that answer your question?
Yeah. But could you hard code it if you wanted
to? Yeah. So I'll show you how to do that in code, actually. So if instead we want to do that with code, I'm gonna first break that connection. So just so you can see, if that selector is not set anymore, then doing the slider doesn't do anything because there's no target or action specified, so it doesn't do anything when the slider changes. So if we want to do this in code, well, the first thing we need is we actually need a reference to the slider. So the way we do that is we'll do that using an outlet, and so that's usually done by just making an instance variable of type NS slider, and then declaring it to be an action. And then now if we look at the app delegates outlets panel, then we can drag from the slider to the actual slider interface element. And so now anywhere within our app delegates code, if we refer to the variable slider, we're referring to that actual slider that we have in our interface builder document. So if we wanted, for example, no, the actual slider itself, the actual object that represents the slider. And so if we wanted now, we can tell the slider that its target is self. So every time something happens to the slider, call a method on self, and the method to call is slider changed.
It's possible to lay out the slider and do like the whole thing in code, but it's
I'm saving you from doing that. I do everything pretty much exclusively in code. So you specify you'll specify like the rectangle that it lives in and all that good stuff. I think we'll talk about that later in the semester. But yeah, you can do everything programmatically. That's how I do almost everything. But again, so now we can see that now we've programmatically set up that target in action. Is everybody with me so far? Okay, so now the next step is when we update, when the slider gets dragged, we want to update the text of the label. And in order to do that, we first need a reference to the label, right? So how do we make a reference to that label? Hint, I just did it for the slider. We're going to make it an outlet. So we're going to make another outlet variable of type... oh, that's right. NS label isn't actually a thing. It's just a text field. It is a text field, right? I can never remember what the type of a label is. On iOS, a label is actually a separate type, but here it's a text. Okay, it's a text field. Okay, so we have a text field outlet, and I'm just going to go into Interface Builder and go to my app delegate and go to its connections panel and see that there is an outlet label that's not been connected. So I'm just going to drag it to that label and say that's our label. Okay? So now just to prove that we actually have that reference, when we launch, let's just log out the text of that label. Label.text. Title? How do you get the text out of the label? Really? String value, there you go. Okay, so now when we launch, we see that we have a reference to that label whose text is label. All right, so now we're basically done. So if we now, in our slider change, we're just going to, that floating point value that's going to come out of the slider, we're just going to say value is sender float value. And then we can just, one of the kind of neat things about Mac labels is that you can set float and int and char and other values directly on them. On iOS, everything has a string value and nothing else. So if we want, we can just say label set float value, that value. And then that will update the text of the label to be that floating point number. Yay. So now as we slide it, the label changes. All right, does anybody have any questions about that app? Yeah. See, a CG float is a type def for float. It's like it's a long float. It's an Objective C type, but it's basically, if you look at the definition of it, it's just a float. Okay. So just a few sort of bits at the end here. We have there's a class NS application that gets automatically created by OSX every time an application gets launched, and it's responsible for running the main run loop of your application. So I think as Glenn kind of mentioned when we talked about auto release pools, there's sort of this run loop that your application sits in where it waits for an event, processes the event, waits for an event, processes the event, and just kind of does that infinitely until you quit. So NS application waits for events to come in from OSX, and then once it receives an event, it will send that event to the object that it makes sense. So if it receives a click event, it finds the button underneath the click and sends the action and tells that button, hey, you've been clicked. If you have an action set on that button, then it will call the action on that button. NS application is the class that owns the main menu nib file on OSX. Not that that's, you don't really need to know, but if you look in the interface builder document, there's an object called files owner. That's going to be NS application. And so you don't ever really talk to NS application directly. That's kind of managed for you by OS 10. The way OS 10 tells your actual code what needs to be done for, say, launching your application or quitting your application is done through the your application delegate, which is just a class that implements a few methods that NS application needs to basically bootstrap your application and quit it. I think I'll talk about that in a second. And so another useful class is NSView, is the superclass of all views in Cocoa. So all those controls, all those buttons, all those sliders, those are all in some hierarchy a descendant of NSView. You can get the position and size of a view relative to its parent using the message frame, which is basically specifies a rectangle of where the view lives relative to its parent. Like I mentioned earlier, views can have subviews, can have subviews, can have subviews, and then there's a programmatic method add subview that you pass in another view, and it adds that to the view. So that if you want to lay out your code programmatically, you'll use a lot of layout. You'll use a lot of add subviews, where you're just creating a view, putting it in a container view, putting that in a container view, putting that in a container view, and putting that in the window eventually. Later, we'll talk about subclassing NSView. So if you're making some custom views, it's common to make a subclass of NSView, and we'll talk about that later. NSWindow is basically a view that's a little bit special. It manages a single window frame of your application. It has a single view within it that's called the content view. And then if you want to put stuff in that view, you just add views to that content view, and then that's the view that that the window maintains. So we have kind of this pretty beautiful hierarchy of views. So views can be within views within views. So we have this sort of hierarchy. So at the top level, you have your window. The window has a content view, and then this view has a box and a label, and then that box has a text field inside of it. And so you can nest these arbitrarily as deep as you want. They get complicated if you make them too deep, but you can nest them as arbitrarily as you want and get these really complicated looking views. Any questions about hierarchies of views? Okay, so NSControl is a special subclass of NSView. It's the superclass of all text fields and buttons and labels and sliders and all those sorts of controls that have some sort of action associated with them, usually. Controls, at least on Mac, typically have a concept of storing some kind of value. So a slider will store some value between its minimum value and its maximum value, some number. A stepper might keep track of some integer value that you're stepping through. A progress bar might have some percentage associated with it for the current progress. Labels will have a string value associated with them. That's the text of the label, and those sorts of things. So there's all these methods: int value, float value, string value, etc., defined on NSControl. So in theory, any of those will work on any control, but some of them may have undefined behavior if you ask for the int value of a regular, like a button. But I guess you could call the method if you wanted. Okay. This is a really scattered lecture. I'm just realizing that. Okay, so there is a really common pattern in Cocoa called delegation. We actually have a whole lecture devoted to this in a week or two, so I won't go into it in much detail. But the main usefulness of delegation is that it avoids the need to subclass in a lot of cases, and basically the idea is an object can delegate some of its behavior to another object. For example, NSApplication delegates a lot of behavior to your application delegate to say, okay, here's what happens when you launch. So it's nice doing it this way so that rather than having to make a subclass of NSApplication every time you want to make an application, you just provide a class that defines a couple of methods that NSApplication needs to be defined in order to run, and then you have an application that's going. There are all kinds of delegates throughout Cocoa. A common one is the window delegate, so you can provide methods for what happens when the window gets resized, or what happens when the close button gets pressed. And you can do these without having to make your own full custom subclass of NSWindow. You can just provide some bodies of methods that will get called by the window on whatever object you want, really, when these events happen. And like I said, we'll talk about this in more detail later. For now, the common one you'll deal with for now is the application delegate, like I mentioned. So there's kind of this is the basic life cycle of an application on Cocoa or Mac. Your application gets started by the user, then the main nib loads, which is called mainmenu.nib on Mac, and then it just sits basically indefinitely in this run loop where it waits for an event, handles an event, waits for an event, handles an event, and does this as long as until you quit. So there are a few useful methods on NSApplication delegate. Again, most Xcode projects, when you make a new project, will provide skeletons for these methods inside of your app delegate, which provides automatically. One is application did finish launching, which gets called after your application launches. So this is a great place to actually get your application going and set up any logic you need. If you have any long-running tasks, you can start them here. So that's kind of the logical entry point to your application. And then at the end, there is application will terminate, which lets you do some last-minute cleanup before the application actually quits. So I know that was really kind of abstract and sort of vague. The lab is a little bit long, but really great and really hands-on. So have fun with that. I have a sign-in sheet again. Just out of curiosity, how many people are still on the wait list? Anybody? Okay, that's good. So I think everybody who's actually attending class is actually in the class, which is what we were going for. So that's that. I apologize in advance for the length of the lab. It's rather long and complicated, but it's really, really useful to go all the way through it. So I highly do recommend that you go all the way through it. Thursday's lab, by comparison, is very short. It's basically porting today's lab to iOS, which actually, as you'll see, is really quite easy. So have fun.